Record. Okay, so yeah. So hi everyone. So welcome to this edition of our Tech Talk. So today we're gonna talk about how you can organize and control uh the use of your cloud resources, specific to your database cloud resources. So I'm your host. So my name is Leo Alvarado, and we have prepared the agenda for today. So today we're going to talk about first we're going to talk about the concept of compartments and child compartments and how you organize it to organize your how you use it to organize your cloud resources. And we're gonna jump into the identity and access management. So I'll be walking you through on how you can write a policy syntax for you to provide your users and groups the desired access level to your cloud resources, and also to review some of the new features that we have, particularly on writing IAM policies to make it more granular on how you can provide the right level of access to your database cloud services. So while we usually focus on building and discussing features, so today we'll be like guardians at the gate, like asking who goes there. And yeah, so we should get started. So before we proceed with the IAM policy discussion, so I'll just do a quick review on the cloud offerings that we have for Oracle Database Cloud services. So Oracle offers the range of database services in Oracle Cloud. So in general, we break it down by the performance and scale requirements for the system, and also where the systems will be reside. Like, where do you want to deploy it? Like, if you want to deploy it in the Oracle public cloud or customer data center, and also who will manage the infrastructure and database. So first is the left is the base database service. So it's built on standard compute and storage options. So offers both Oracle Database Standard and Enterprise Edition, and it's typically used for workloads with smaller processing and data storage requirements. Then you have the Exadata database service on dedicated infrastructure in the public cloud, and Exadata database service on cloud customer, which are both built on the Exadata platform, and as a result, offer the highest performance, scale, and availability, along with all of the Oracle database options and functionality of Oracle Database Enterprise Edition. Exadata database service on cloud customer offers the same cloud economics and cloud automation as Exadata database service on dedicated in Oracle public cloud, but it is deployed in customer data centers. And then if you want a fully autonomous and managed by Oracle, so we also have the autonomous database, which is available in the Oracle public cloud on shared or dedicated Exadata infrastructure, or in customer data centers on Exadata Cloud at Customer. So it's very simple to utilize the OCI console for you to manage this Oracle Database Cloud Services. So you can use the navigation menu in the upper left to navigate to the database service pages where you want to create, manage, and view your cloud database resources. So for example, um, Exadata database service can be managed from the web console by first selecting Oracle database in the navigation menu. Then you can either select Exadata database on dedicated infrastructure, which is available on Oracle Public Cloud, or Exadata database service on Cloud Customer, which is available on Cloud at Customer. And in terms of cloud automation, so database cloud services comes with this ready cloud automation built in for performing lifecycle management. So cloud automation simplifies most lifecycle and management tasks. So including adding additional servers and scaling OCPUs up and down, creating databases, database homes, scheduling your infrastructure maintenance, updating and upgrading VM operating system, grid infrastructure, databases, performing backup and recovery options, recovery operations, and even enabling disaster recovery protections through data guard. And this is relevant to what we're going to discuss, as you can also control the permission and access for performing this different lifecycle management for your database cloud services. So let's start with first on how you will organize, like how to start with a clear resource organization. So we're gonna talk about users, groups, and compartments. So this is just a review. So when you subscribe to an OCI, or even you configure your tenancy, so you'll be creating a user. So a user, it's an OCI resource, which let's manage or use your organization OCI resources. And a user, this could be a user that needs to launch instances or create database or create your Exadata database service instance, or even manage your virtual cloud network. And then this users, you can add it into groups. So a group is a collection of users who all need the same type of access to a particular set of resources or compartment. And then you also have the concept of dynamic group. Like dynamic group, so these instances act as a principal actors and can make API calls to services based on the IAM policies that you have written and assigned for that dynamic group. So, and then you have compartment. So compartment is a collection of related resources that can be accessed only by groups that have been given permission by the administrator in your organization. So I'll just go through some of the considerations when it comes to compartment. So a compartment can be deleted after creation or renamed. A compartment can have subcompartments, or we can also call it child compartments. And most of the resources, so same with database cloud services, so most resources can be moved to a different compartment after they are created, and that child compartments or subcompartments, so they inherit the access permissions from compartments higher up its hierarchy. And then when you create a policy, so you need to specify in the IAM policy which location to attach it. So location, it refers to, it could be your tenancy or specific uh, compartment. And then, as I mentioned, so compartments can have subcompartments or child compartments, and this child compartments inherits the access permissions from its uh, parent compartment. And there are several ways to organize your cloud resources using compartments. So you can organize it based on your software development lifecycle, or SDLC. So in this example, so we have created two compartments. So one for non-production environment and then the other one for production environment. And that each compartment has also been modeled to have two subcompartments that divide the resources between database resources and application resources. And this allows for easy separation of administrative responsibilities. And you can also organize your resources based on departments. So you can create multiple compartments based on your organization departments. Like you can have like a compartment for your finance, HR, and sales, and then and then on your department compartment. So you can create a child compartment for your database compartment and also your application compartment, and that you can put all your database cloud services resources under the database compartment. Or you can have a combination of both software development lifecycle and also departments. Like for this example, you have an SDLC compartments for your non-prod and prod environment, and then inside that, you also can create different compartments based on your uh, departments. So that's how easy you can use compartments to organize your resources. So now we go to the next one, in which how you will define the control, or how would you define how resources are used. So in OCI, you have a concept of service limits and quotas. So when you sign up for OCI, or when you subscribe to OCI, so a set of service limits are configured for your tenancy. So service limit is the quota or allowance set on a resource for the tenancy. So you can view your service limits in the console. So you just need to go through governance and administration, and that under the tenancy management, you just need to select limits, quotas, and usage. Under the limits, quotas, and usage page, so you can so if you wanted to view the service limits for your database cloud service, so you just need to select database under the service, and then for the resource, so you can select whether it's for Exadata database service, base database service, or autonomous database service. So you can view your initial tenancy limits, but you can submit a request to increase your service limits also from within the console. So in the same page, so there's a button there for you to raise service limits request. And there's also a concept of OCI compartment quotas. So the compartment quotas, it lets you control how resources are consumed, and you can even restrict a compartment usage to a required set of resources. So for this example, you can uh, create a quota policy. Like this one is just to restrict the resources specific to your uh, total storage for your autonomous database for dedicated on to 30 terabytes on that specific compartment, which is the shared PM. And that the OCI compartment quota, so it can be applied on compartments and even your sub compartments. Okay. Now, in terms of the permissions and access, so let's talk about the OCI IAM policies. So OCI IAM policies, it lets you control who has access to what. So OCI IAM policies, it's a policy. I mean, it's a document that specify who can access which resources and how. So a policy simply allows a group to work with a specific type of resources. So that will be for all OCI resources in a particular location. So it's either tenancy or a compartment. And that users gain permission to use resources based on the groups that they are mapped to. So if you look at the second bullet point, so policy simply allows a group to work with specific types of resources in a particular compartment. So that's basically the basis of the policy syntax for IAM. So when you're creating an IAM policy, so the syntax is very straightforward. It's allow subject. So subject is the group. So that could be that will be your group name. Two, verb. So for the verb, so you have different set of verbs for different resources. So you can inspect, read, use, and manage. And then for the resource type, you can use the aggregated resource types. Like for OCI, you have the instance family, which for your compute. For database cloud services, you have your database dash family. So that's the overall aggregated resource types. And then, or you can also use the individual resource types. Like for database family for database cloud services, so you can specify an individual resource type. Like for Exadata database service, so you have your cloud infrastructures, cloud VM clusters, DB nodes, DB homes, DB backups. So you can also use that individual resource types. And then in location. So location, that could be it could be your tenancy or a specific compartment. And then on your policy syntax, you see there at the top, you can add where uh conditions. So you can add where conditions for you to specify permissions and even to the actual API operations for that resources. So now let's go to some of the examples. So for for this setup, so you have your database cloud services resources in your database compartment, and then we have created a group. So you have a group here, which is dev DBA group. So the first use case is that we wanted only to allow the members of our dev DBA group to create VM cluster and then perform some of the database lifecycle management like clone backup databases, but not to terminate the database or not to terminate the cloud VM cluster on Exadata database service. So the IAM policy, it's very straightforward. So in this policy statement, so you can use conditions combined with permissions or API operations to reduce the scope of access granted by a particular verb. So for this example, since we only want them to perform the lifecycle management, but in the policy, as you can see here, so allow group dev DBA group, that's the group name, to manage. So manage is the verb. Cloud VM clusters, that's the individual resource type, which is your VM cluster for Exadata database service. In compartment my demo, where request that permission is not equal to cloud VM cluster delete. So now here we're adding a where condition clause in which we are not permitting the group to perform that permission cloud VM cluster delete. Then same as with database. So you can just add the where clause here in which it says where request that permission is not equal to database underscore delete. So this one, it lets you restrict the deletion of your database and VM cluster for that specific group. Or you can also create a policy uh, for you to manage resources in a specific region. So let's say, for this example, I just want to allow the members of London DBA group to manage both the VM clusters and databases in a specific region, which is London. So the policy simply allow group London DBA admin, so that's the group name, to manage cloud VM clusters in tenancy where request that region equals LHR. So LHR, that's the region identifier in OCI for the London region. So same as with the aggregated type resources. So if I just wanted the London DB admins to manage all the database cloud services, then I can create a policy like allow group London DB admins to manage database dash family in tenancy where request that region is equals to LHR or London. So, and then this example, this is to show you if you want to just allow the certain members of London DB admins group to manage VM clusters only for a specific region and until a specific time and day. So in your work loss, you can also include like a request.utc dash timestamp for you to define like a specific time of the day when are they allowed to manage the resources. So for this example, uh, let's say I wanted to just allow the London DBA admin group to manage databases in my demo compartment between working hours, like 9 a.m. to 5 p.m. Pacific Standard Time. So the policy is that allow group London DBA admins to manage database family in compartment my demo, where request that UTC's timestamp that time of the day is between the 9 a.m. and 5 p.m. Pacific Standard. And note that the time of the day is calculated based on UTC. So if you live in a time zone that implements daylight savings, then you will need to update the policy when the time changes. So this is how you include multiple where conditions for the time on your policies, then you can even assign a more granular OCI permissions for your resources. For example, for the VM cluster update operations. So this is an enhancement feature that we just released. So you can now assign granular permissions for virtual machine, for VM cluster operations for Oracle Exadata database service on Cloud Customer and Oracle Exadata database service on dedicated infrastructure. So, for example, you can enable the database administrator group to just perform scaling of memory or OCPU, or allow your storage administrator group just to manage the local and Exadata storage, or only permit your security administrator group to add the SSH keys to your cloud VM cluster. So this enhancement provides a fine-grained control over the VM cluster update operation. So for this example, let's say that we just wanted to allow the members of the DevDB group to only scale OCPU. So on your IAM policies, you can call a the where condition. So the policies allow group DevDB group to use Cloud VM clusters in compartment my demo, where request that permission is only equals to Cloud VM cluster update CPU. So this one will just let them to update and to scale up the OCPU. And then if you wanted, for example, to just allow that specific group to perform grid infrastructure update in any scale operation. So you can have this sample policy. So it's allow group, dev DVA group to use Cloud VM clusters in compartment, my demo, where any request that permission. So this is for the up scale OCPU, Cloud VM cluster update CPU. Then the scaling of the storage is the Cloud VM cluster update Exadata storage. Scaling of the memory is Cloud VM cluster underscore memory. And then local storage or the file system storage, that's the Cloud VM cluster update, local storage. And then for performing the updates for grid infrastructure, so that's the request that permission equals to Cloud VM cluster update GI software. And if you want to, for example, allow members to perform any operation except adding SSH keys to your VM cluster, then you can have the sample policy in which you're just allowing group DevDV group to use Cloud VM clusters in compartment where all and that the exception is that request that permission is not equal to Cloud VM cluster update SSH key and request that permission is not equal to updating the VM cluster. So this is the way if you want to restrict the adding of SSH keys to the cloud VM cluster. And then the other approach is that you can just allow or you can just allow the specific uh, permissions for that specific group. Like if I wanted to just allow the members of my storage admin group to scale my local and cloud Exadata storage, then I can just simply write the sample policy. So here, I'm allowing the group storage admin to use VM clusters in the compartment my demo, where any of the requested permission is only equal to cloud VM cluster update Exadata storage. So that's for the Exadata, scaling for the Exadata storage, and then scaling for the file system storage is the Cloud VM update local storage. And then you need to add the allow group storage admin to use the Cloud Exadata infrastructure where the requested permission is Cloud Exadata infrastructure inspect. So you need to add the inspect verb and also to add the permission for the Cloud VM cluster uh, inspect. Okay, so after creating this sample policy, so you can easily create it from your policy builder. And then once that you create it, so you'll see here that we're just allowing this group just to perform the scale for the Exadata storage and local storage, and for them to display and inspect the infrastructure as well as the VM cluster. So this storage admin group. So when they try to add SSH keys to the VM cluster, so they'll be getting this uh, error. So since the add SSH keys is not included on their permission, so when they try to add SSH keys, so they'll be getting this authorization failed or requested resource not found. And then when they try to perform the scale operations, like for local storage, so, yep, they can simply perform that life cycle, and then after the scaling, it will show that the VM cluster gets updated with the new value for the local storage, and yep, and then you'll see that now it's available with with after the scaling. So that's how easy it is for you to use uh, compartments to organize your resources, and IAM policies for restricting some of the specific permissions or API operations for the different resources on your database cloud services. I've also shared the new enhancements, especially for the VM cluster update operations. And yep, so with that, showing you the references. So these are the permissions and API operations that I have used in the demo. And so we have a linked here for the updated permissions and API operations details for Cloud VM clusters for both Exadata database service on dedicated and also on database service on Cloud Customer. We also have the how-to guide. So this one shows the same demo flow that I have shown for you to assign a granular OCI IAM permissions for VM cluster update operations. And then for more resources, so we have an external Slack channel where we upload all our get started guides, how to demos, I mean, the replay of this tech talk and also the featured blogs. So if you want to join our Slack group, so just go to the join link, and then once you join the via the join link, so you just logged in your email for your Slack, check email for code, and set up your 2FA, and that's it. So welcome to our workspace. And yep, so that brings this session of Tech Talk to an end. And again, I wanted to thank everyone. And if you have any questions, so feel free to post in the Q&A.